Hey YouTube, another video, and this time I'm quite excited because I'm gonna be upgrading my small electronics hobby lab that I have going on here. As the title suggests, you already know I'm gonna be making myself a benchtop power supply, a decent one, using an old computer power supply. I watched a lot of videos on YouTube, the more common ones that come up on the highest results, and then also less viewed ones, just to get insights on different ways that people go about it, different designs that they make for their benchtop power supply, because I'm not just gonna stick to this box which has rails coming out of it. That's easy, you don't need to do any sort of special modifications for it. But if you want to have it nice in a box and also have voltage ratings, adding later on a buck boost converter so that I can produce different voltages, then this is the way that I'm going for it. Now before I start, I would say that up until now I've been using this variable transformer. It can vary between 3 volts and 12 volts, unregulated, and it can provide up to 1 amp of current. It's nice when you're just experimenting with small circuits, but once you go, you want to make larger things, more circuits that need to power up and it needs more current, then you need to have a decent power supply, which is the purpose of this whole project. This video is not going to show you how to go about it, how to cut wires or solder them. I think it's pretty obvious. The purpose is to share some insights which I thought were lacking from other videos that I saw up until now. So to start with, here is my power supply. I'm going to put it like this so that you can read the ratings and see everything. And this is not your generic ATX that you buy at a store. This one comes out of a Power Mac G4. It has a non-standard for PC connector for the main board, 22 pins, unlike the 20 or 24 that you will find for a standard IBM compatible. One thing that I saw about almost all the videos that I've seen about this sort of project is that most of them focus on giving explanations about the power supply that they have, the standard one with the standard colors and the standard outputs and everything. And then comes the question, what if you have something like this that comes out of a Mac? It might have different pins, different outputs, different things that you need to know, different colors also, and how you go about it. I noticed a lot of people commenting there, asking about various power supplies that they have that don't match what the videos are explaining, and hopefully in this video I will be able to share some insights on how to go about it in a methodical way and not just instructions on a specific sort of power supply. The first thing that I would like to start with is just showing you how to power it on, how to test it, how to know how to go about it. Naturally, before you do any sort of work, before you start investing your time in it, cutting wires and modifying things, you want to know that the unit is working. You want to know how to power it on, so then later you don't come to a step, nothing happens, and you don't know what to do further. So the first step would be to turn it on and just get a general reading about it. So the first thing that you would do before I even plug it in is, if you know the model of the PC that the power supply came from and you suspect that it's not standard, and even if it is standard, just your standard ATX power supply, you go to Google, you type in standard power supply Pinout, and you will get an image just like you see at the bottom in a moment, that will show you exactly the pins that come out of this main connector. Many videos would suggest that in the process there is conversion, or some of them would say hacking in ATX, which I find a little bit silly. There is no conversion here, there's no hacking here. This unit was designed to give out fixed voltage rates. As you can see here, different models through the years would give different outputs, but at the end of the day, this unit was designed to give DC voltage, and we're not converting it, we're not hacking it, but what we do for the most part is repurposing it. So this unit was designed to power up a PC. The only thing that makes this unit designed for a PC are these connectors at the end. By trimming the connectors and then doing whatever, maybe putting our own connectors, or maybe just using the outputs from these wires, putting them on terminals, we are repurposing it. So that's the whole thing that we're doing. I'm repurposing this power supply so that eventually it can be used in my whole benchtop power supply setup that I'm making. So the first part is, as I said, go to Google, find the pinout for your exact model, and the next thing, we're gonna power it up. As you can see here, I don't have on this model a power switch, so that means that when I connect the power to it, it will immediately go into standby mode, just like that. Don't know if you heard it, but there was a little zap here inside. Just to make this example clearer so that you can see it on the camera, I have here this fan that I took out also from the Mac, and I'm going to connect it back to the output that it was connected to, and you can see that pretty much nothing happens. The fan, let's see, yeah, the fan doesn't turn on, but it is in standby mode now. These end connectors, they would have just a 12 and a 5 volt output, and they're irrelevant. The most important thing is this connector right here. And if you look at the image that is at the bottom of the pinout for this specific model, a PowerMac G4 Quicksilver, this is revision B. We're gonna see in a moment why I'm mentioning this. But what we do, we take a multimeter. That would be the second step after you got the pin out. You want to verify that indeed the pins that you have on your own power supply, they all match the pin out and everything. We're going to take the ground and just connect it to one of the grounds here, just like that. And we're going to take the positive, and we're going to check every pin according to the pinout that we have. I'm not going to go through every pin here, there's no real point for it, but you can see in the pinout, for example, that we have a pin number 15, which suggests that it is the power switch on pin. If I probe it, then you can see that I'm getting 5 volts on the output, so that's good. If I go to pin number 13, which is supposed, if I remember correctly, I don't have it in front of me, but it should be the negative minus 12, but it doesn't give anything. Also, if I put it on the 3.3, we don't get anything. If I put it on the 12 volt, we don't get anything. If you look at pin number 22, then you'll see that we're supposed, we get a standby output of 25 volts, and indeed when I probe it I get 25 volts. Now earlier I mentioned that this is a revision B model that came out of Mac, or the Apple, sorry, or the manufacturer of this. If you look at the pinout, you will see that pin number 9 suggests that there is no connection there, so there shouldn't be a wire in there, or there should be a wire, but it's not connected anywhere. Where if I probe this pin, I get a 25 volt output again. So my idea is that the pinout that you see in the image came from revision A, the first units that came out. I read online that there were problems with these units, and then Apple went and they replaced them on the guarantee contract because there was an issue with them. So this is, as you can see, the pinout says that there shouldn't be a connection when in fact there is. So that's why it's important to measure these, to know exactly what you have. Don't trust only the coloring of the wires. If I probe again a pin, the power switch pin, and then I go and check the wire itself, it's green, so it sort of matches the general color schemes that would come on a power supply. But if this would be a different color, then I wouldn't be able to trust it only by the color, and then it's important that I probe it. So now we know where the power switch is, and the next thing to do will be to turn this unit on. Right now it's not on. You can see that the fan is not turning, nothing is happening. The most ways that you go about turning these units on is by shorting out the power switch and the ground, and that basically should turn it on. So let's try that, and let's see what happens when I do it. So I would take a jumper wire and I would connect it to the power switch on, and the other end I would connect to the ground. And right now you just saw, I will do it again. I disconnected, now it's connected. It starts up briefly, but then it stops. It stops because it doesn't have a load on it. It doesn't detect that there is any load on the right rail, even though this fan is a load and it is sitting on the 12 volt line. If you look at the ratings right here, you can see that 12 volt will provide 13 amps, 5 volt will provide 18.5 amps, and 3.3 volt will provide 24 amps. So we always want to put the load on the rail that has the highest output. Just to test this, I have here a load. I have here my my 5 watt 12 ohm cement resistor, and I'm gonna take this and I'm gonna place it. We already have a load on the 12 volt. We know that it's not working, so I'm gonna place it on the 5 volt line, and we're gonna try it again just to see what happens. So if I take this and I place it between the 5 volts and the ground, and let's hope that it sticks. Yep. And then again I take the power connector, I'm connecting it, and we get the exact same result. The power unit turns on, and then after a moment it stops. It stops because again it doesn't detect the load on the correct rail. If we take this now and we connect it to the highest one, the 3.3 volts, which I have right here, and I'm going to connect it just like this and into one of the commons, just like this. And once again I will take my jumper wire and connect it between the power switch on pin and just hold it like this. Right now you can see that it's working. If I measure, I should have disconnected it. If I measure the output pins, then I should be getting everything you already see here, that I have 12 volts, so we know definitely that we get that. If I probe the 12 volts, no. So here we go. We're probing the 12 volts. I had a little disconnection here, and we're getting 12 volts on the output. If I probe the 3.3, we're getting 3.3, and if I probe also the 5 volts, just take it from here, would be easier, then I'm getting 5.2. So everything is working. We can see that we probed it. We know exactly what does what. This load will start heating up slowly, so eventually we'll also use a heatsink for it. But this is the first step. Again, doesn't matter which power supply you have and which model PC it comes out from. It is important that you go, first of all, look for the pinout for this mainboard connector. The next thing that you do, you probe it, you make sure that you're getting all the right outputs that you're supposed to be getting. If there's anything that does not correspond to the pinout, just like you saw with pin 9 for example, that shouldn't have a connection but it does, then you need to notice so that you won't make any mistakes later on with the wires. And then as a last definite measure, you can also look at the colors and then also see if the colors correspond. But that would be the last step, and if the colors don't correspond, then you always have the measurements and you know exactly what's happening. The next thing that I wanted to talk about is an issue of design. Again, watching different videos, some of them showed a better design, some of them showed just your standard design, pulling out the rails, putting a box on top, and that's it. My plan for it is a bit more sophisticated. I want to have something that actually will give me some readings and that I can expand on. So the one common thing that I saw is that people start to modify this box here, this casing of the power supply. They make it open, they drill holes in it, sometimes in a very unsafe way. They add switches and connectors and LEDs and everything on this case. I'm not going to do that, simply because I think I see it as a bad practice. This unit was designed to give out, to do a certain task, and in the same sense that you won't buy a PC that has this unit built in, fixed in, and these wires soldered to the motherboard. You won't buy it because you will think to yourself, okay, well, what if this unit fails, or what if the motherboard fails? Then I need to start making all these modifications and opening it up, removing everything that I've put inside, and place it in a different power supply. That's bad practice. No one does it in the professional world. You buy a module and you put it as part of your product, and then if the product goes to a customer or a client or sits somewhere, it has a problem, you need to service it, then you would come, take this model out, put another one, and it's back in business. And that is as opposed to opening it up, starting to remove everything, desoldering everything, remove all the connectors, all the things that you want to salvage out of it. I'm sure that some of you would salvage it either way, including myself. I would remove all the heat sinks inside, they're very useful. But other than that, as to put in your power supply, in your own application, I wouldn't go about modifying this case in any sort of way. The only thing that we're doing with this is, again, repurposing it, and that happens on this end. We're only going to remove these connectors and repurpose it for our use. So I will put this on the side for a moment, and just to show you the design that I'm going to take, I have this box, which was just a box which I received once. It had candy in it from work, and it had these little drawers in it like this. And I removed everything. It had a shelf. It had these dividers here. I removed it all, and I have a nice wooden box for my variable, not yet, but to be power supply. It has a lot of room in it. This unit will eventually sit inside. It will sit inside either this way or that way, but it will sit inside. I will fix it. I will put rails here so that it doesn't move, and these wires will eventually be spreaded out. Some will go from here to the load, and some will go to the front of the panel. You can see that it gives me a lot of room to work with. Hopefully the zoom of the camera, yeah, it's good. It's gonna have a main switch. It's gonna have all the output voltages. It's gonna have a bunch of ground so that I can connect it. And then later on, I can also add a buck boost converter inside. I can add a display here for a digital voltmeter display, pots for the boost converters, and I can add a lot of things here that here, if I start to modify this unit, then it doesn't give me a lot of room. This specific unit that is designed by a company for Apple, everything, just like all Apple products, is cramped inside. There's not a lot of room in it. The second important thing about just modifying this box and just using this power supply in this box is that, as you can see, this one has a rating of about 350 watts, and it's quite low for a power supply. It's an old one. I think it comes from 98 or around that year. And if tomorrow I will find a different power supply that has 450, 500, 600 watts, instead of having again to remove all this scrap that I've placed on the original casing, I will just remove this unit from this box and then put the new unit inside, plug it in, repurpose it, and I'm good to go. That pretty much sums up the way that I'm going to go about this project. These were insights. I'm not going to share with you any of the work here. I don't see any purpose for it, but I will show you in a few seconds the final result. Obviously I'm going to go and do it, but for you it's going to be just a few seconds. You're going to see the final result in this box with the parts that I already have. I don't have them all, but I will show you which parts I'm going to start with. So first of all, I have my load here, two 5 watt 12 ohm cement resistors, which I'm going to connect in parallel. I have here this custom heatsink that I made for it, and they're basically going to sit here inside and clamped by this thing with the screw, and it's going to come here. The wires are going to come through this splitter here. I have a small fan that's going to push air out of the case. I have these connectors which I once took off my professional breadboard, which later on I found out that it's shorting out everything. A switch for the power on switch, an LED with a resistor for a power on indicator, and then I also have the main switch, and it's this one. This will connect to the main power, and this part here I will cut it and I will connect it to these three in a nice way, and then the only thing I need to do is connect this inside the box, and again connect these to the output terminals, and that's about it. This is going to be the way that it's going to be, that it's going to look like in this video. So stick through, you'll watch the end results, and I'm going to go about doing this. Okay, so I'm back, and as you can see, here's the finished result, open of course, and I'm quite happy with it. It came out really nice. As you can see, I have a lot of room here in the box to add some more things later when I have them. The power supply fits nicely inside. It has this backing wood here at the bottom that prevents it from moving anywhere in the box. I added this fan. Here we have the dummy low, the two 5-watt 12 ohm cement resistors that are connected to the 3.3 volt line. And again, as you watched at the beginning of this video on how to power this up, you connect them to the rail that has the highest current rating. Again, if anything happens with this unit, the only thing I need to do is I need to unplug it from here and remove these wirings, and then I can just pull it out, place a new one inside, and everything else stays the same. I added a main switch right here inside, and here there is just the power switch that will turn on the 12, 5 and 3.3 volt rails. The 25 volt and minus 12, I bundled them. I don't have any use for them right now, and they're just bundled here inside in case I want to use them in the future. I also left two grounds, one 5 volt and one 12 volt, also bundled just like it came originally, because I have this idea that later I will pull them out so that I can power on hard drives and just computer things, and I can mess around with them. Here you can see the output rails. I have the ground, 12 volt, 5 and 3.3. I didn't use the original connectors that I showed because they were too short to fit the thickness of the wood. So I just used the standard M6 screws, 30 millimeter length, and the caps fitted on them nicely. And they're all isolated, so this is a wooden box. You want to make sure that everything, all the connections, the DC, the AC, everything is isolated from the wood. For that I drilled holes, and I've placed a piece of just cut marker here, and I made these small pieces and I fitted them inside the hole, and then I placed a screw on each side. There are two of these plastic M6 rings. They ensure that everything is isolated from the wood, because the wood eventually can can absorb moisture and it can create a short. I'm going to add some videos here because this whole thing doesn't fit inside the frame, just so that you can see different perspectives of it and what it looks like. I painted the box, I made it nice and black, but that's it. There's not a lot to say further about all the connections in here, because I explained it in the first part of the video. This is just basically a nicer way of doing everything that we did at the beginning, powering this unit on and making sure that everything is working, but only a bit more user-friendly with switches and everything nice and closed. I'm going to power it up just for a moment so that you can see. I've turned the main power on, and now I'm turning the main power for the unit. It's still not on. Once I raise the switch, then everything starts working. The indicator LED, I originally showed the red one, and that was the plan, just to put it here in front. I even drilled the hole, but eventually I didn't use it because I had this idea, and that's about it. It gives all the right voltages, everything is working nice. I left it on. It doesn't heat up, it doesn't do anything that it shouldn't be doing. So yeah, I'm really happy with the results. To top it all off, what I had the panels left over from the Power Mac. This is the panel. I just cut it out. It was bigger, but this basically fits this little LED right here, and I can just put it like that inside. And I need to also fasten it, but basically this is the cover. And again, if I turn it on, once I raise the rails, once I turn the unit on, then it will give out this nice light here at the top. I hope that you can see that. Maybe I'll just turn these two off. Yeah, and now you can see it. And back on. This is it. I hope you like this project, and I hope that you like the video that I made and the insight that I shared with you. And that's it. Thank you for watching, and I'll see you next time.